Jacob, how you doing there this evening? This is just going to take me a few minutes here, and I'd like to go over these problems. We've done half of it with you. But let me just review real quick. What is an orthocenter? An orthocenter is one of the 4 different kinds of centers in a triangle. And that would be the centroid, the circumcenter, the incenter, and then you have the orthocenter. The orthocenter is where all 3 altitudes intersect. So I'm drawing an example of one right now. So if we have an altitude there, and then if you were to have another altitude, I'm just doing a quick sketch here. And then if you have a third altitude, and again, altitudes they just create a right angle. They don't necessarily go through the middle. And where those 3 altitudes cross is the orthocenter. But the beauty of it, you already learned way back ago that in order to have a point, you only need 2 intersections of a line. So when you're working with an orthocenter, or to find it, all you need to find is the intersection of 2 of these lines. And to find the intersection of 2 lines, you're going to be solving for equations of lines with 2 variables. So in the specifics we have here, if we were to have an XY graph, so let me redraw this one with D, E, and F here. Here's your 0, 0, your origin. Y graph, X graph. And we have D at 0, 0. And then we have E at 3, 6, so over 3, and up 6, so that's going to be E. And then we have F at 4, 0. Here's F. All we have to do is find the intersection of any 2 altitudes. Now there's one altitude you already figured out, and that was this altitude here, the altitude from E going down. We already figured out that this equation of a line, we're at 1, 2, 3, so one of our altitudes is simply the equation x equals 3, and that is a line. So all we have to do is choose any other one, any other altitude, and then we'll get our orthocenter. So here, if we, from F, if we were to draw a line that is perpendicular, and we want the equation of that line right here, there's a couple steps. One, you just want to write the equation of the line. Y equals mx plus b. So the first thing we have to do is we have to find the slope. The slope of this line is going to be 3, because you do 6 minus 0, 3 minus 0, and you already know that the slope is 3. So the slope of DE is 3 over 1. So for perpendicular lines, you know slope times slope equals negative 1. So 3 over 1 times something equals negative 1. That means our desired slope has to be negative 1/3. So we know this line right here, our desired slope has to be negative 1/3. Now, we still need B. Problem is we don't have it. But you always check and see what you do have. We do have a value of x, and we also have a value of y. So you take that value of x and value of y, and we're going to plug it in. And I think we got this far in class. So we have 0 equals negative 4/3 plus b, and that means our b equals 4/3. So our second equation of line, the purple one, is y equals negative 1/3x plus 4/3. So the question arises is where do these two lines intersect? And to get that coordinate, we're going to use substitution. So we have to find the intersection of these two lines, x equals 3, and then y equals negative 1/3 x plus 4/3. The beauty of it is you already have one of the coordinates that you need for the orthocenter because we already have the solution for x equals 3. So all we have to do is find our y coordinate here. So we can use substitution since we have the value of x. We're going to plug it in here. We get y equals negative 1/3 times 3 plus 4/3. Of course, we solve, and these cancel. So y is going to equal negative 1 plus 4/3. Let's get like denominations here. So that negative 1, of course, changes to negative 3/3 plus 4/3. We're going to add the numerators there. That's negative 3 plus 4, so it's 1/3. So this is going to be positive 1/3. Now, you take a very close look here. I'm going to get really close and see if this is actually the case. Now, this is not. So taking this really close, let's plot these points. And if we were to plot this completely accurately, which I was just doing a quick sketch here, is you're going to go over 3. So it is 1, 2, 3, and then up 1/3. If we drew this completely accurately, it wouldn't look like a single point. So that coordinate there is where that orthocenter is 3 and positive 1/3. So to recap, to find an orthocenter, you find the equation of a line for two altitudes, and then solve for their intersection. And you can use this, you can either use substitution or elimination. Let's see if we answered all the questions up here. Plot, we figure that is out. Find the slope of E to D. Find the slope of a line perpendicular to ED, which we did, by the equation of a line that goes through ED through point F, which we did down here. The equation of the line was y equals negative 1/3 x plus 4/3. And then what we did is we found the intersection of this line, x equals 3, and y equals negative 1/3 x plus 4/3. Let me plot these points up here, be a little bit more accurate. So over 3, up 1/3, be about right there. If you take a look, and if we were to graph that, I'm going to graph that in light pink. This is a little bit more accurate because it's drawn to scale. And you can see, lo and behold, that hits at a right angle. And at that point of intersection right there, that red dot is over 3 and up 1/3. You didn't say anything about the beginning problems, but I cut and paste them here. I'd like to go over that real quick with you. A centroid is also called the center of gravity. And whenever you connect the midpoint, corner to midpoint, corner to a midpoint, and corner to a midpoint, where those three medians intersect, that's called a centroid. And it's also called the center of gravity because if you were to actually do that in the triangle, you'd spin it on top of a little triangle, and lo and behold, you are going to get a center of gravity. And it says, to find that centroid, if the vertices of a tray have these coordinates, to find the coordinates of the balancing point, what you do is you simply average the x coordinates, and then you average the y coordinates. So here, if we have A is at 0, 0, and B is at 9, 0, and C is at 0, 6, if you wanted to figure out where the centroid should be, you average the x's, Zero plus 9 plus 0, divide by 3 in this case, and then you average the y's. So your centroid, if you were to plot these, is going to be at 3, 2. So let's go ahead and plot that. I think it'd be easier to see how this works if you can see that plotted. So let's do this in the first coordinate. And A is at 0, 0. And B is at 9, 0. And C is at 0, 6. Okay, so here's your triangle. And then we found the centroid is at 3, 2. Over 3, up 2, and that would be the balance point, right there. That's the centroid. So that's number 9. It says if the waiter's hand is at the balance point and the distance from his hand to A is 16 inches. So from his hand to A is 16 inches. Find the distance from his hand to BC. Well, we learned that when you have a centroid, that centroid creates a 2 to 1 split. So this is 2x, and this is x. And we just found this is 16. That's going to make this half, which is 8 inches. So it will go 8 inches because you have a 2 to 1 scenario. I hope you found this helpful, Jacob. Sorry it took me a little bit longer to get to you. Happy to work with you when you come in on Friday.